Hey everybody, since we didn't get a chance to go over the test interpretation in the webinar, I want to go ahead and do that for you now. So here we go. So this is the test report for the quadriceps. At the top we see two graphs. The graph on the left is concentric and the graph on the right is the eccentric. The blue lines represent the right side and the red lines are for the left side, which in this case are the involved side. We can see by looking at the graphs that even though the left limb on the concentric side did very well compared bilaterally, it has a significant eccentric shutdown as the range of motion increases beyond 50 degrees. And remember, we want that range of motion to peak out around 60 to 70 degrees or beyond. I outlined three columns here. The left is the numeric data for the concentric side, the middle is the eccentric data, and the right side is the ratio of the two. The first row of data is for peak torque. The middle row is the work per rep, which is analogous to average torque for the entire range of motion, and the bottom row is the data for power. Let's look at the peak torque data. Concentrically, when compared bilaterally, as with what most therapists do, he's actually 1% stronger on his surgery side. But when we look at his torque to body weight, he achieves only 65%. And we know that with research, this should be 100%. So what he actually has here is significant weakness bilaterally in the concentric mode. On the eccentric side, he has only a 17% strength deficit compared bilaterally. But let's look again at his body weight comparison. He hits 82% of his body weight with his uninvolved limb and only 68% with his involved side. Now, ideally, the peak concentric quad should be 100% body weight, and with appropriate training, research tells us that the eccentric should be 10 to 30% greater than concentric. So that means we're looking for a peak torque eccentrically at peak torque to be 130% of his body weight, and he's nowhere near that with either leg. In fact, with the surgery leg, he's only about half of that, and with the uninvolved side, he's 63% of that. So big eccentric deficits bilaterally. The difference is that his uninvolved limb doesn't show that big eccentric neurologic shutdown like the involved side does after 50 degrees. The ratio of eccentric to concentric for the right side is not bad at 126, but the left side is only 105. And again, we want 130% for this eccentric to concentric ratio. Next, let's drop down to work per rep data. And this tells us how strong the average strength is throughout the entire range of motion, which I think is more important than just the peak torque. He actually is 5% stronger compared bilaterally. But let's look again at his body weight numbers. Now, in a moment, when we go to the eccentric side, we're going to tell you that we want his average eccentric work per rep strength to be 100% of his body weight. And given that there's a 30% greater eccentric strength, that means that for the concentric side, we want this to be about 75 to 80% of his body weight. So again, we see a big bilateral concentric deficit. Eccentrically, we see a 22% bilateral deficit of the involved side. But let's look again at that body weight comparison. Remember what I just said about the eccentric work. We want it to be 100% of the body weight, meaning that for the average strength throughout the range of motion, the athlete should be able to handle their body weight with just the quadriceps for decelerating the knee. Here he hits 78% on the uninvolved side and 61% on the involved. So here's where you see the difference in that strength over the entire range of motion versus just the peak torque. This gives you a better understanding. And if you look back at the eccentric graph, he matches the torque curve well until about 45 to 50 degrees, and that's where that drop off occurs. Now, this isn't abnormal for us to see because a lot of our athletes at this point have been doing step downs and things like that, and working in that 0 to 45, 50 degree range, but not going any deeper than that. Again, our ratios mirror what we saw at the peak torque data. When we drop down to power, we see that his rate of force production deficits pretty much mirror his strength deficit numbers in both concentric and eccentric. Lastly, let's make a note on the coefficient of variance, and this is a measure of how closely the 3 reps match each other. We're looking for a 10% variance or less, and some people allow up to 15%. Now, his test was very good. He only had a 0.06 or 6% variance maximum between all of his reps, and that's a good test. And we always see a very low coefficient of variance with the interrupted stroke test. This is the hamstring report. Like with the quad, we have the concentric graph on the left and the eccentric on the right. The right limb is in blue and the left is red. And again, that's the patient's involved side. So you can see he has deficits throughout the range of motion in both concentric and eccentric modes. The peak torque for the concentric hamstring shows a 16% deficit compared bilaterally. With the body weight comparison, what I'm going to do is take the parameters we use for the quadriceps, but use 60% of those numbers, as we know the hamstring should be about 60% that of the quad. So here we want the peak torque hamstring to be 60 to 70% of the body weight. His uninvolved side hits 38% and the involved side hits 32%. So again, both are only just half of what we want. Eccentrically for peak torque, we have a 12% bilateral comparison, but for body weight, we're looking for about 80% of his body weight. Again, I took the 130% body weight from the quad and multiplied that by 60%, which gives us 78%. So I just rounded it up to 80 to keep it easy. Here, our athlete hits 52 and 46% of his body weight with the uninvolved and involved side, respectively. So again, we're just over half of what we're looking for. The ratios look great here as they're both well above 130%. So that tells us he's got a good eccentric training to the hamstrings. Dropping down to work per rep or average strength for the hamstrings, concentrically, we see he has a 22% deficit compared bilaterally, and the body weight data here should be about 45 to 50% of the body weight, and he hits 37 and 29 with the uninvolved and involved side. Eccentrically, we see the 29% bilateral deficit, and the body weight standard here is 60% of the body weight. The uninvolved gets close at 50%, and the uninvolved is at 35%. Again, we have good ratios. As with the quads, the power data for the hamstrings mirrors his strength data. Now let's look at the hamstring to quad ratios. The standard way to analyze this is with the concentric hamstring to the concentric quad, which gives you a ratio ideally of 0.6 to 0.8. But given that you now have eccentric data, you could look at this differently. You could look at the eccentric to hamstring to the eccentric quad, which again should be 0.6 to 0.8. But we like to take what's called the functional ratio, looking at the eccentric hamstring to the concentric quad. And what we want to see is that they're very close to each other for a ratio of 1.0. And this is important because the hamstring will fire eccentrically against the concentric quad to control that tibial translation anteriorly. And we want this to equally match each other. Here's an outstanding article by Ruiz et al., which recently was published in 2019. And it looks at the functional ratio and it describes it. So check it out as it has great information about that. So if we look at our athlete's numbers and the ratios, the ratio for the standard con, his right uninvolved side was at 0.66, which is good, and his left was at 0.49. So really not far off from that 0.6 that we're looking for. We pretty much get the same ratio if we look at his eccentric hamstring to his eccentric quad. But if we look at his functional ratio, he's only at 0.89 for the uninvolved and 0.59 for the involved limb. So this again shows us deficits that we wouldn't have picked up on unless we tested eccentrically. So let's interpret the test. If we only did the standard con test, we would have seen that his quad strength was great, 1% stronger on his limb symmetry. His hamstring would have shown up as slightly weak at 16% deficit, so I listed this as red because you want 85 to 90% limb symmetry. Also, his ratio would have come up as deficient, but again, just outside of that normal. So we would have said, go ahead, get started with your return to sports activity, and we would have felt confident sending him back to play. But if we use the interrupted stroke test looking at the eccentrics as well, we would have picked up on his huge bilateral quadricep deficit with that significant neurologic eccentric shutdown on the involved side. We would have picked up on the hamstring weakness bilaterally, and using the functional ratio, we would see that there were bilateral deficits as well. So when his athletic trainer sent him to us at 5 months post-op in April, she knew that he was nowhere near where he should be, and she wanted him to see those objective measurements firsthand. So after this test, he went home for the summer break and continued to work on strengthening aggressively. He came back in August at 9 months post-op, and he increased his strength by about 30 to 40%, which was better, but not where he needed to be still. So he continued working on his strength and rehab with his athletic trainers, and he returned to us in October at 11 months post-op. And at that point, he met his minimal strength requirements, and we felt confident sending him back to full college level lacrosse.